Box. Welcome aboard to NEET and JEE Enlite, your Vedantu channel for all the JEE and NEET aspirants in English medium. And today we are proceeding towards Gauss's law, how to apply it, what is Gauss's law, how to get there, and some really cool and amazing problems on Gauss law and its applications. So stay tuned till the end, and looks like I'm visible as well as audible. Hello Venkata, hello Attitude Boy. And guys, the way I would know that you guys are here is only through the chat box. Make sure you stay tuned, make sure you keep interacting, and make sure you keep putting up the answers in the chat box as we proceed. So let's begin the class with me, Shreyas, your physics master teacher from Vedantu. And I hope that you have smashed the like button as well as the subscribe button. Alright, shall we begin, guys? Come on guys, need your full josh, need your full efforts, need your full participation, need all those students who are in 12th standard, who are preparing for JEE and NEET to attend this class, to learn from this class, to enjoy the class and score good marks. Now, also remember there is a link for joining the Telegram group, and in the Telegram channel you will see that you will be getting the PDF of today's session. Not just that, all the important updates and notifications I'll be keeping on messaging or keeping on telling you on the Telegram channel. So make sure you are in the Telegram channel. So let's start with a quick recap, and let's start with this. So Kalyan Venkat, the way to cover backlog is to have a systematic step-by-step approach with small chunks being covered over a long period of time, and watch some lectures which are crisp, clear, so that you can simultaneously make notes and solve problems rather than a big lecture. It might take some time, but in a planned, systematic way you can do it and devote 20 to 50% of your total time in covering backlogs. That will help you. Now, in the previous classes we have studied about flux. Let's do a quick recap. Flux is nothing but directly proportional to the number of field lines which are piercing through a surface, and if I have some surface, let's say like this, you can take small area over here. Okay, well, we'll come to that part later on, but there will be some electric field lines cutting through it like this. So the flux directly depends on how many lines are exactly cutting through this particular surface. So that decides your flux. More lines, more flux. There is another way of defining the same flux. Flux can be defined as electric field dot the area vector if the field is uniform, and if it is a flat surface. But if it is non-uniform and it is a curved surface, then you take the electric field and take the dot product with the area vector at each location and you integrate it. So this is when it is non-uniform curved surface. Non-uniform, or basically some kind of a curved surface. So what I mean over here is that you see what is the electric field at any location. You see at that particular point what is that area vector. The area will be very small. This vector will be your area vector. Take the dot product, that is going to give you the flux in that small area. You sum up, basically add up all the fluxes through all such small areas, that is integration. So E dot ds summation gives you the total flux. Is that clear? I hope this is understood. This was something which we have done in some of the previous classes. All right. So hello Vara, hello Ed, good evening Ujwal. Nobody knows RDJ Ironman when is JEE exam, but it is expected it will be anywhere between January to March. Alright, January chances are less, but most likely in March. Hello Priyarthi, hello Vara Lakshmi, good evening, hello Anushree, good evening guys. So let's start now with the main chapter, and that is basically your Gauss's law and application. And before proceeding, I just want you to see if you can solve this question. This is there in many books also, but let's see if you can get it. There is basically a plate and there is field which is cutting through it, and the field is basically along the same plane as that of the area. Oh, interesting. The field lies in the same plane as that of that square surface. how much flux is associated, the electric field makes some angle theta with the normal drawn over there. Let's see how many of you can do this. Hello Princey Dubey, good evening Bachalo, good evening my warriors. How much flux will pass through that plate? Now a lot of you will be thinking I might have to take some angle, some component and all of that. Well, that's not true. In fact, if you see, the field lines are basically parallel to the surface. This is the surface and this is the field in the same plane. Because they are in the same plane, there is no piercing. There is no piercing of field lines. Hence, the flux must be zero. That's it. There is no doubt about it. If you start now, yes, you can definitely do it. Just like the last year, your seniors have done it even within 1 year. But you need extra hard work and you need extra patience and you need extra focus. Definitely it is possible. There is another way of looking at it. If you notice, the electric field vector is over here. Area vector is always perpendicular to the surface. So strictly speaking, the area vector will be towards me. So the angle between the area vector and the field vector, you can see it is 90 degrees. So theta is 90. So cos of 90 is going to be 0. Hence the flux is going to be 0 because flux is E vector dot area vector. So the dot product is also going to be 0. So answer is D, 0. Is that clear? I hope this is clear. Okay. RDJ, don't cry. Like I told you, like you have to start now and you have to continue. Okay. So watch the class. Don't just think, oh, sir, can I do it? Can I not do it? If you keep thinking, can I do it? Can I not do it? Definitely it will not be possible. But if you start doing it, if you start attending the classes, definitely it is possible. Let's move on now to the main Gauss's law concept. Okay. So I have some questions. I'm going to ask those questions. I want your answers and replies in the chat box. And even if you're going to watch this recorded, it's okay. You can think of the answers in your mind and see whether it matches what others are saying and what is the actual answer. So imagine, guys, I take up a positive charge. Imagine I take up a positive charge, all right? And let's say I basically consider a Gaussian surface around it. So I consider, let's say, a surface around it. This is basically a closed surface, closed surface. Now, any closed surface is basically called as a Gaussian surface, Now, what is the meaning of closed and what is the meaning of open surface? Simply put, imagine you take your bag, your school bag, or let's say your carry bag, something maybe like this, all right? Some carry bag like this, some carry bag, okay? So the carry bag has an opening, so it is an open surface. But if you put the zip or stitch it or you close the bag, it becomes a closed surface. A balloon that you blow, if you do not tie the knot, it's an open surface because there is an opening. The moment you squeeze it, tighten it, tie it out, it's a closed surface. So any closed surface synonymous with Gaussian surface. Just like you guys have names at your home. You might be called Pandu, you might be called Champa, you might be called Motu, Laddu, whatever. So a closed surface is also called as a Gaussian surface. Now, if I tell you, is there any field which is cutting through the Gaussian surface? I think so. Like you can see, there are these electric field lines which are cutting through it. So, if I ask you, is the flux positive or negative, you will remember the sign convention which I have told. In case you do not remember that, I will write it back over here. If you have a closed surface, last lecture I have told you this, if there is any flux which is coming out, then that flux is positive. Then it is considered as positive flux, and any field lines which go in, then it is considered as negative flux via convention. So any flux which is outwards is positive, any flux which is inward is considered to be negative. So if you think about this question over here, where did it go? Okay, yeah. If I ask you, is the flux through this surface positive or negative? Well, your answer will be, it is just going to be positive. Is that right? It's just going to be positive because all the field lines are just coming out. Great. Now, here is what I'm going to do. If I consider some other surface around it, let's say my surface looks like this. Let's say my surface looks like this. Now tell me, is the flux still positive? Well, if you think about it, through every point on that blue line, the field lines are coming outwards. So hence, the flux through this surface is also going to be positive. Is that right? Now, my next question is the flux through the white surface and is the flux through the blue surface going to be same? Think closely. Is the flux through the blue and the white surface going to be same? Or maybe the data is not so much sufficient to figure out the answer. If you think a little bit carefully and recollect the definition of flux, you will realize flux is how many lines are cutting through a surface. It's directly proportional to that. Now, if you look at the white surface or the blue surface, you will notice one thing. Any line that cuts through the blue surface will also cut through the white surface. Any line that cuts through the white surface also cuts through the blue surface. It's non-negotiable. It will definitely cut through it, no matter where you go. Yeah, it might cut later on, but it cuts. So I can definitely see that this flux is definitely equal to this particular flux because the same number of lines are there, right? Very interesting. Now let's take another example. Let's say I take up a positive charge over here and let's say I see that these are the field lines coming out of it and I take up a Gaussian surface. Let's say this is my closed surface or Gaussian surface. Now what I do is I increase the charge inside this. I add some charge. Maybe I make it more positive. The moment I make it more positive, the moment I add some more positive charges onto it, what will happen? There will be more field lines coming out of it. Because of that, what will happen? The flux will definitely increase. Very, very interesting logic. Everybody with me on this? So the flux is definitely going to increase. Great. Now let's try out something else. What if I take up a negative charge? I know that the electric field lines will come inwards. Now, if I take some random surface around it, I will see that this flux is definitely going to be negative by sign convention. Any field lines which go inside a closed surface is negative. Everybody with me on this? Awesome. Now comes the next part. What if I take either a positive charge or a negative charge? Let's say I take a positive charge. I know the field lines are going to look something like this. These are the electric field lines. But this time, the surface that I am drawing, Gaussian surface, is like this. Now tell me, what is the flux through this Gaussian surface? Come on guys, think about it carefully. What is the flux through this yellow surface? Hello Vasu, hello, very good Nandu. Come on guys. Everybody, hello Lord, good evening. Whatever field line goes in also goes out. Whatever field line goes in also comes out. Whatever field line goes in comes out. Whatever is in is coming out. So there is no residual flux. There is no thing which is originating or terminating. Hence, the flux through this surface is definitely going to be zero. Everybody with me on this? Yes. Okay, let's try out something else now. Maybe we will take up a positive charge and maybe we will take up a negative charge right over here. Now, if we draw the field lines, if we draw the electric field lines, they will look something like this. They will look something like this. It will come like this. It will definitely come like this. And there will be so many more such field lines. Let me take some Gaussian surfaces and see how does the flux get affected by it. Let's say I start with a Gaussian surface here. If I take a Gaussian surface here, think and tell me, is the flux going to be positive? I think so, because you can see all the field lines are definitely coming out of that charge. Definitely this flux is going to be positive. What if I take this as my surface? Observe this carefully now. I'm going to take this as my surface. observe this. This is my surface. Come on guys. What will happen now? What will happen now? You can see whatever field line is going out is also entering in. Whatever field line is going out is also entering in. Whatever field line is coming in will definitely also exit out. So basically, the number of lines going out are the number of lines going in. In this case, the net flux is definitely 0. Net flux is 0. In fact, if somebody chooses this as his Gaussian surface, even in that case, the net flux will be 0 because whatever is entering in is exiting out. All these scenarios are leading somewhere. And I'm pretty sure by now you would have seen some kind of a pattern. And you would have seen some kind of conclusions that you would have probably framed in your mind if you have been here from the start. If not, rewind back and see all these situations. In every situation, you will see that the closed surface flux completely depends on the charge that is inside. If the charge is positive, flux is positive. Charge is negative, flux is negative. Also, if there is no charge inside that particular surface, there is no flux. Not just that, even if there is a charge, but the total charge is 0, then also the flux is 0. That means the net flux completely depends on the charge which is present inside the surface. Like if I take the surface here, you will see that the charge enclosed is positive, so the flux is positive. Also, if I increase the charge, the flux increases, and that's why I would say that the flux completely depends on the charges present inside. So I think I have a conclusion that I can make. If I draw a Gaussian surface, okay, this is basically a Gaussian, or basically I would say closed surface, and I take up some charges which are inside as well as outside. Let's say these are the charges which are inside, Q1, Q2 and Q3 and so on and so forth. So basically Qn. These are the inside charges, and let's say there are some charges which are outside. Let's say capital Q1, capital Q2, capital Q3, capital Q4 and Qn. These are the outside charges. So I would just write it over here. So Q is basically inside. Q is basically inside. Capital Q is nothing but outside. And all these charges will give rise to some kind of an electric field. Obviously, like this Q1 at let's say this point might give some electric field like this. This Q might give some electric field like this. This Q might give some electric field like this. This Q might give some electric field like this. This Q might give some electric field like this, right? And so many charges are there. Even this charge might give some electric field like this. The resultant of all these fields, I'm just showing it. Okay, this is just the resultant at any point on the surface. So this E is basically the electric field due to the inside as well as outside charges, both of them, inside as well as outside charges. And this electric field will be there everywhere. Remember that there will be electric field line passing here, who knows, everywhere there will be some kind of electric field lines. I'm taking one such electric field line, and at that point obviously I can show some area vector. This is that area vector right over here. So what I just saw over here was that the net flux through a closed surface is completely directly proportional to the enclosed charge or the charges inside. Enclosed charge, that's all, nothing else. Now this net flux in that closed surface, I can also write it as integral electric field dot area vector. Electric field dot area vector will be the flux, but since it is a closed surface, I will symbolically put over here a cycle or cyclic symbol, that is just to tell the particular observer or user that yes, listen, you have to integrate everything, you cannot leave any surface. Complete surface has to be considered. This is the closed surface flux. And this proportionality constant proportionality constant, I'll keep it as it is. Enclosed charge will be nothing but your Q1 plus Q2 plus whatever charges are there inside. Now this proportionality constant, I can convert it into an equality. So it will be 1 by epsilon naught. That is the constant of proportionality. And this is nothing but the charges which are basically inside. And this is your total flux, electric field dot area vector. This is the proof, or you can say the manner in which Gauss's law can be framed. Electric field dot area vector's complete surface integral, closed surface integral, is 1 by epsilon naught times Qn. The constant of proportionality is 1 by epsilon naught. Everybody clear till this point? This is your Gauss's law. Now I have put it up over here as well. Probably we can start solving some questions. Let's see. Here is the first question coming up on your screen. The figure shows below the distribution of charges, the flux of the field due to these charges on this surface S. This is the surface S, is how much? Put up the answer in the chat box. No, it's not one short video. This is long-term series of videos. Okay. Come on, guys. What should be the correct answer? Manjeet, maybe you can put up the doubt after the session is over in the chat box or in the comment section. Maybe I'll have a look at it. Now, if you notice, for this particular surface, this and this both are inside. So the net flux, because it is Q in by epsilon naught, so it will be Q plus Q by epsilon naught. So it will be 2Q divided by epsilon naught, which is definitely option B. It is 2Q by epsilon naught. This charge will not matter because this charge is outside. Always consider the charges which are inside. Like I have told you over here, charges which are inside should be considered. Charges which are outside are never to be considered. Moving on to the next question on your screen. Very good, Mukund. Hello, Tarshan. Welcome aboard. Here is the question. A charge Q is enclosed by a Gaussian spherical surface of radius R. Now, if the radius is doubled, the new flux will be half, same, doubled, increased 4 times. Beautiful question. Let's try to understand the diagram first. A charge Q, so there is a charge Q and it is enclosed by a Gaussian surface of radius R. So let me draw a Gaussian surface of radius R. So let's say this is my Gaussian surface and this is nothing but your radius R in the first scenario. Now, what will happen? This charge will definitely create some field lines. It will go like this. All right. These are the electrical field lines which are going to come out of this charge, and they are also going to intersect through the Gaussian surface. Now, in the second scenario, if the radius is doubled, so you take a spherical Gaussian surface of double the radius, of basically double the radius. So this is 2R. Question is, which flux is more? So one is flux phi 2 and the other one is basically your flux phi 1. Which one is more, which one is less, how many times? That's the question. Now, if you try to think this way, sir, as we go far away, field will reduce and flux is field dot area. So because field is reducing, flux will reduce. That is completely wrong statement, because when you go far away, yes, the field will reduce because it spreads out, but the area also increases. So field reduces, area increases, they compensate. So the flux remains the same, but a better way of looking at it is counting the field lines. Whatever field line intersects the yellow surface also intersects the blue surface. There is no doubt about it. There is no field line which intersects yellow and does not intersect blue, or vice versa. So all the field lines pass through both the surfaces. Hence, the answer should be basically they are going to be equal. Doesn't matter how big you draw. Even if somebody draws a crazy surface like this, some crazy surface like this, as long as the charge enclosed is same, you will see that this surface will also have the same flux. No doubt about it. Okay, because the charge enclosed is always the same, and you can see the field lines are also the same. Great. Moving on to another question coming up on your screen, and here it is. A 2 coulomb charge is placed at the center of a cube. What is the flux through any one surface? Good evening, Anuraga. Hello, Lakshat. Ramya, long time no see. Hello, Teja Gamer. Yes. JEE Mains is easy than NEET? No. JEE Mains and NEET are almost at the same level. JEE Mains might have few questions which are more mathematical than NEET, but Pattern is also different, obviously. This has 45 questions, this has 25 questions and all of that. Pattern is different. Negative marking is there. Level of questions roughly similar. Little bit, I can say JEE is slightly higher than NEET. Not much of difference in these last few years. Maybe a long time back, if you see 2003, 2004 papers and all, that time used to be very difficult, JEE. But these days, JEE has become very easy. Okay. So maths, I'm talking only about physics, guys. Maths paper is difficult, but physics, chemistry of JEE and NEET is roughly the same. Okay. Let's try to solve this question. First of all, I think we will draw a cube. Let's try to draw a cube over here. This is our cube. Okay. Great. Okay, so this is our cube, guys, and what have we done? We have placed a charge of 2 coulomb at the center. So let's say this is the center where you have placed the charge. What will happen? This charge will create field in probably all the directions, maybe like this, even like this, even like this, even backwards, everywhere. There will be field going everywhere in all the directions. So I know that if I have to find the flux through any one face, let's say for example, I want to find what is the flux through this particular face. I know that the flux through any one face, because there are 1, 2, 3, 4, 5, 6 faces of a cube, I will say it will be 1/6 of the total flux through the cube. Do you guys agree with this? Whatever flux will pass through the cube, it is going to go symmetrically. Whatever goes up will go down, will go left, will go right, will go front, will go back. So whatever flux will go through any one face will be 1/6 of the total flux, because there are 6 faces. So what is the flux through the cube? It will be nothing but the charge inside divided by epsilon naught. What is the charge inside? I think it is given to be 2 coulomb divided by epsilon naught. So 2/6 becomes 1/3, and that will be epsilon naught. So 1/3 epsilon naught. So where is it? Option A, of course. Some of you are saying, yeah, everybody was saying A. Yes, nobody said B, thank God. What is meant by C and what is flux? Hounds, you should watch the previous class. C is coulomb. I have explained what are charges. And there are beautiful playlists, guys. For those of you who want even more lectures, don't worry. If you're on the channel, all you need to do is watch this playlist, hit on this playlist tab and go down below over here, and you will see JEE NEET class 12th PCMB. You see this Pathfinder 12th physics. This is a playlist of all the classes that I have conducted last year, and I want you to go through this. There are some lectures like do this before joining 12th or before studying 12th. So go through all these basic math and basic vectors and gravitation related lectures. Then you can see right from electrostatics to Gauss's law, current electricity, till the last chapter, semiconductors and communication systems, everything has been done. So watch this in addition to these live classes. If you just watch this, it is still good. But if you just watch the live classes, I would say no. You have to watch this plus this. That will give you a very good understanding of the topics. I hope that is fine. All right, hounds? Great. Chalo. Let's move on now to the next question coming up on your screen. It's a statement-based questions. Now, I don't know how many of you know this, but in the last few years, it has been found that these kind of statement questions are very common. Be it JEE, be it NEET. They give you some concept, they give you some theoretical statements, they play around with the words and ask you which is correct, which is wrong, and stuff like that. Let's try to do this. Can you crack JEE Advanced in 10 days? Definitely, Madala, Tejasri. You can crack JEE Advanced in 10 days. Basically, all other students who are working for 2 years, what do you say about them? Maybe they should not have worked for 2 years. I think they should have also just waited for the last moment, and maybe they should have just asked, can I crack JEE in 10 days? Yes, definitely. You can definitely crack JEE Advanced in 10 days. There is no need to study for 2 years. Why to waste 2 years? 10 days are more than enough. I think JEE means within 1 day or 2 days you can easily crack it. Hello Suji, nice to see you back. And see guys, which of the following statements are correct. If the flux of the electric field through a closed surface is 0, then electric field must be 0 everywhere. Electric field may be 0. Charge inside must be 0. There must be no charge inside. Now, before even going through the statements, I will think of all the possibilities all the possibilities of the situation where, if the flux is 0 through a closed surface. So let's say I have a closed surface like this. There is a possibility that I have a positive charge and I have a negative charge of equal amount, positive and negative, because of which whatever field line goes out also comes in, and that's why the net flux is basically 0. Possible. This is one possibility. Another possibility is I have a Gaussian surface and I have some charges, but these charges are just outside. So it doesn't really matter. Whatever flux goes in comes out, or like this. So the charges are basically outside. Then also flux is 0. Yep, this is one more possibility. And another possibility is you just have a Gaussian surface and there are no charges at all. Everywhere the field is 0. There is no field only. At least here, there are field lines which are going in and coming out. Field was there which was going in, coming out. Here there is no field. E is 0. These are the only possibilities. Under only these circumstances will the flux be 0. Now check out the statements. Electric field must be 0 everywhere. No, here electric field is non-zero. Like you can see at every point, electric field is definitely not 0. In this case, electric field is 0. Must be is definitely wrong. So must be is definitely wrong, guys. This word should not have been there. Electric field maybe it is not 0, maybe it is 0. Maybe possibility is there. So there is a difference between maybe and must be. Madala, if you have prepared well for mains and if you have been preparing for advanced, definitely you can crack advanced. You can improve your scores in the last 10 days. Watch the classes, solve questions, solve PYQs, give mock tests, analyze your mistakes, be focused, work hard. Lot of improvement can happen in the last 10 days for JEE Advanced. Don't worry. Okay? All right. Next, the charge inside the surface must be 0. Wrong. There can be charges. The charge inside the surface must be 0. Yes, the total charge inside the surface, whatever is positive is negative. The charge inside the surface is 0. Charge inside the surface is 0. Yes, it must be 0. Only then the flux is 0, because flux is nothing but Q in by epsilon naught. So Q in must be 0. There must be no charge. There is a difference between net charge 0 and no charge. Here there is no charge. Here there is no charge. Here there is charge, but the values of the charges cancel. So hence this is definitely wrong. So 2 and 3 are correct. So that is option B, I suppose. Option B. Very good, Manjeet. Very good, Dikshita. Awesomeness, guys. Very good. So what are the medium weightage topics on JEE Advanced Physics can you suggest? Fluids, thermo, medium weights. Okay. And maybe, I cannot say what is medium weight, what is high weightage. Guys, I don't know, have you seen my advanced classes? If you have seen the advanced classes and have you seen the previous year advanced paper, you will realize the questions are always mixed. Like I won't even say that this question is from this chapter, this question is from this chapter. There will be a question from 2-3 chapters. Option is from some other chapter. Like, there could be a question on electric field and gravitation with Newton's laws, and the options are on SHM and options on something else or vectors. I have solved these kind of questions. So there is a mixture of things. I wouldn't be able to, or in fact it is wrong to even commit to a weightage for JEE Advanced. If you are doing that, you are just deceiving yourself. What about this question, guys? 5 charges are there fixed at these positions, and there is a Gaussian surface over here. If you use Gaussian law, which of the following statement is correct? Look at the diagram, see which charges are inside, see where is the Gaussian surface, see which charge is outside. The question is, which of the following statement is correct? Hello, Harsh. Okay, great, Hounds. What is the difference between studying in any NIT and top 5 NIT? Placements, the culture, the research, the respect or the value that your college will hold when you apply for post-grad programs, all these things. Same thing like what is the difference between NIT and IIT or something like that. Okay. So what do you say, guys? Let's see how many of you are getting the correct answer. See if you have marked the answer as option B. The electric field on the LHS will be from all the charges. The charge is only from Q2 and Q4. Now, I don't know whether you remember this. I just told it some time back when I explained Gaussian law. When I write this electric field is both because of inside as well as outside charges. This charge, this charge, this charge, this charge. All the charges give field. This E is the net contribution of all the fields. But whatever you write on the RHS is only because of the charges which are inside. So LHS has the field contribution because of all the charges. RHS has the charge contribution only because of the inside charges. Hence, the correct answer for this question will definitely be B. Electric field is because of inside and the charge contribution is only because of Q2 and Q4, which are basically only inside of it. Everybody with me on this? Great. Let's now move to some application problems of Gaussian law. I will start with the application of Gaussian law to a point charge. You will see some very interesting thing. Then we'll go to line charges and maybe something else. Let's start by applying Gaussian law to a point charge. Now we all know if I have a point charge, let's say Q, the electric field line coming out of it will look something like this. So I'm just going to show the electric field lines coming out of a point charge. These are the electric field lines. I will try to find the electric field at some distance r from the charge. Because I want to find the electric field at some distance from this charge, I know maybe I can use the Gaussian law. Maybe that electric field can lie on the surface. Maybe via some formula or some integration I will get it. So because I want to find the electric field at some distance r, at some distance basically r from the charge, how about considering a Gaussian surface which is also a sphere? This is basically a spherical Gaussian surface, because I know at all the points on that blue sphere, everywhere the field magnitude will be same, direction is also same. It is outward. So maybe the calculations will be easy. Whenever you choose a Gaussian surface, try to make the field either parallel or perpendicular to the surface, and always choose the points where the field is same, so the calculations become easy. So here field is directly outwards. I know the magnitude is same everywhere because the distance is same. So maybe things might turn out to be a little bit easy. So if I happen to choose an area vector, anywhere, this is your area vector and this will be the field, electric field at that point. The angle between the electric field and the area vector will be 0, because I can see clearly electric field is parallel to the area vector everywhere, be it here. Everywhere area vector and electric field will be parallel, so angle is 0. The advantage of that is that when I take the dot product, it becomes simpler for the calculations. Now, here is what we are going to do. Let's apply Gauss's law and see what happens to that surface. So if I apply Gauss's law, so Gauss's law is nothing but cyclic integral electric field dot area vector will be the charge inside by epsilon naught. Now the electric field and area vector both are parallel, angle is 0, so it will be nothing but electric field into area vector into cos of 0 degrees is equal to the enclosed charge. In this entire surface there is only one charge, which is Q, so I'm just going to put Q over here divided by epsilon naught. Now the best part of the problem, because of our spherical symmetry, I know everywhere the field is same on the surface. Everywhere, here, distance is same, field's strength is same. So because of which I can just shift this electric field outside the integration. Any time you have a constant, you can shift it outside the integration. dA remains, cos 0 is obviously 1, so it is just going to be Q by epsilon naught. Now what does this mean? It is basically adding up all the small areas out here. Area this, if you add, you're going to get the total surface area of the sphere the total surface area of the sphere is nothing but 4 pi r square, and this is nothing but q by epsilon naught. Shift these people here. So electric field will be nothing but q by 4 pi r square epsilon naught, but slightly in a better form. This will look like this. Electric field is 1 by 4 pi epsilon naught, and you will have q, and you will have this small r square also. Now what is the best part about this? The best part is, from Gauss's law I got Coulomb's law. Coulomb's law was exactly this. Like if you multiply by the charge, you will get the force. Force is some constant into q1 q2 by r square, or field is some constant into q by r square. So from Gauss law you can get Coulomb's law. From this you can do the reverse and you can get Gauss's law. Now, very important thing. A lot of you might be wondering, sir, in the Coulomb's law I remember there is one constant, Coulomb's constant, 9 into 10 to the power 9, it is written as 1 by 4 pi epsilon naught. Why do you want to write 1 by 4 pi epsilon naught? Sir, where did that 4 pi come from? That 4 pi came from this derivation. Epsilon naught was assumed constant in the Gauss's law. When you integrate, when you solve the problem, you see that 4 pi comes. That's how that 4 pi comes as the Coulomb's constant. Everybody with me on this? Everybody with me on this? Cool, clear how to apply Gauss's law. So we have taken a point charge. How about taking some another geometry, and that's basically a line charge. Let's try out a line charge and see how it comes out to be. So line charge means charges are aligned on a line, or basically you take a wire which is charged, and let's see how it works out to be. So imagine these are our charges. These are our charges. They are on a line. So let me just draw that line like this. And basically this continues downwards as well as upwards till infinity. Now because of these line charges, there will be electric field symmetrically distributed around it. So any charge will give electric field outwards or inwards depending on whether it is positive or negative. Now these charges, because they are in a line, their field lines will just come radially outwards in every plane that you consider. So if you take field lines over here, one field line will come like this, one field line will come like this, another field line will go like this, another field line will go like this. If you take a point here, one field will go here, another field will come here, another field will go from the back, another field will come this side. So this is how the field lines will look like in every plane. Now, in order to find the field at any distance r from this line charge, by the way, I also define a property called as the linear charge density. Some of you might have heard this term. So lambda is basically called as the linear charge density, and the unit for this is basically coulombs per meter. That tells you, if you take 1 meter, how many coulombs of charge is present in that. How many coulombs of charge is present in that. Kalyan Venkat, you will get daily practice problems in our normal pro courses. You get assignments, you get Tattva module, and you also get additional content, and these additional content along with assignments are for every sessions. So make sure you are a part of the pro subscription so that you get all the daily practice problems with solutions, everything. All right. So that's where you're going to get it, bacha. Now, once I know that lambda is how much charge is there per unit meter, the only thing left is, how do I calculate the field at any distance r? Well, if I take any distance r, I want to find the field. I know at the distance r, no matter which side I go, the field is the same from here, 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 here. The intensity will be same. Just, yeah, the directions are different. So maybe I will choose a Gaussian surface which is symmetrical like this. So maybe I can think of a cylinder. Maybe I can think of a cylinder out here. So let's draw a cylindrical Gaussian surface. Maybe goes like this. Observe this cylinder, right? So this is nothing but a cylindrical Gaussian surface. Cylindrical Gaussian surface. Now in this cylindrical Gaussian surface, let's assume the height to be h. Let's assume the distance at which you want to find the field is r. At any point on that Gaussian surface, okay, let's say you take over here, there is, let's say, some kind of electric field E, and at that point there is also some area vector which is going to point outwards. So this is my area vector. Again, I see that my area vector is parallel to the electric field vector. That means theta is definitely 0. I can do similar things what I have done before. Now I will do one thing. I'll apply Gauss's law and see what happens. So cyclic integral E dA cos theta, which is cos 0, will be nothing but Q in divided by epsilon naught. Now I know at any point on that curved surface, the field is same. It's a constant value, so I can very well bring it outside. So electric field comes outside, and I have integration of that area. Cos 0 is anyways 1. Inside charge, I do not know. I'll find it out. Also keep one thing in mind. Although I have taken a cylindrical surface, some of you might be thinking, sir, what about this flat surface below and on the top? Well, let me tell you, the field lines are only cutting through the curved surface. There is no field which is cutting through the flat surface on the top or bottom. So don't even bother considering the area of the top and the bottom, because the flux is only going to contribute in the flux. The top and the bottom part, the field lines are parallel, they are not piercing through it. You can only consider flux when the field pierces through it, not when it is parallel. Yes, Rudra, definitely. Yes, Megha, only the curved surface area will release flux. Great. Now, what is the charge which is there inside? The charge which is there inside the Gaussian surface, that's the cylinder, will be, well, maybe I can use this concept over here. Lambda is the linear charge density. That's how many coulombs is there per meter. How many meters is there inside the cylinder? How many meters of that wire is there inside? H meters is there. So the charge which is inside, the charge which is going to be inside, think about it, the charge which is going to be there inside will be lambda into H. Are you guys agreeing with this? So this should be lambda into H. Lambda is coulombs per meter. How many meters? H meters. So lambda coulombs per meter into H meters will give me that many coulombs. I hope this is clear. Now Venkataparavan Devadakura, if you just search for strategy 2023 Shreyas sir, you will get the video. I have already made a beautiful block-wise strategy video. It's already been released. You should watch that. There is no point just keep on making strategies newer and newer. It will be just waste of your time. I know a lot of you just keep looking for strategy videos, but when it comes to actually applying, then you don't follow it. So guys, make sure whatever videos have been already made, it's the strategy which will help you for NEET or JEE 2023. Block-wise strategy has been given. Please follow that, bacha. Okay? NEET results should come, bacha, anytime. It should come by today or tomorrow. I don't know. It's not coming yet. I don't know what they are doing. So maybe sleeping. So now the area's integration will only be the curved surface, which is, what is the curved surface of a cylinder? 2 pi r is the circumference, h is the height. So basically this will be nothing but 2 pi r into h is equal to lambda h by epsilon naught. Here I have only taken the curved surface because the flat surface, the flat has no contribution, or basically the flux is 0. So for the flat surface, the contribution is 0. Okay, now I can clearly see from here this h and this h got cancelled, and therefore I'm going to get the electric field as 1 by 2 pi epsilon naught, 1 by 2 pi epsilon naught. Lambda is there on the top and this small r is there below. Great. So that is my final formula which I'm going to remember. 1 by 2 pi epsilon naught lambda by r. Some people also like to remember this formula like this. Multiply and divide by 2. So 1 by 4 pi epsilon naught becomes your coulombs constant. This will become 2 lambda and divided by r. One and the same thing, guys. It's one and the same thing. Okay. Okay. Yes, I have given all the chapters which you need to cover block wise. Just search for it, bacha. It's there on this channel only. Okay. You just have to go over here and basically search. Where is it? Just go over here. You see this? Search. Okay. Just click on this and just search for Shreyas sir 2023 strategy. Just search for it. You will get the answer for this. Where did it go? Did it go somewhere? Oh my god, I don't know what just happened. It should have come. Wow, my system is behaving crazy. But yes, if you search over there, you should have got it. I'm not sure what just happened over there. This should have come. Okay, 2023 strategy Shreyas sir. Okay, just search. Yes, there you go. This is 1 year roadmap for JEE NEET 2023. Block-wise strategy has been given, and 5 things that you should do, foolproof plan, everything has been given. Just search for it. Okay, both the videos you can watch. Everybody fine? Cool? Great. Chalo, let's move on to the next one. And similarly, you have another question or another application of a plane charge density where you have a sheet, which has sigma coulombs per meter square. So you have basically sigma as the surface charge density, In that case, this is in coulombs per meter square. If you have a sheet which is uniformly charged, it will create an electric field both ways, like this as well as like this. And the best part about this electric field is uniform in nature, uniform field. So if you have a sheet like this which is charged, you will notice very quickly that the electric field because of that, is just going to be parallel lines. So it is just going to be uniform. And you can again apply Gauss's law. I'll leave it up to you. I have shown the hint how you will take the Gaussian surface. Try it out on your own. You will get the electric field to be sigma by 2 epsilon naught. This is the value of the electric field because of a sheet which is uniformly charged. Everybody with me on this? Will you be able to do this? Can we go to some questions? Hello Manish. Dharma Teja, maybe you should start watching my videos regularly right from the beginning. Maybe if you missed some topics, start from lecture 1. You will understand it. That's my promise to you. Samuel KK, I have started class 11th long time back. It's already there in the playlist. It's called as the Legend series, long time back. Okay. I've got, okay, I'm not here right now for counseling, bacha. So right now we are focusing on this chapter. Okay, we are focusing on this chapter. Let's move on. Great. Chalo. So I have put up some pointers over here which will be available in your Telegram channel. So make sure you go through it. Here is the first question on the application part. Okay. Thank you, Venkata Pavan Devakonda. Thank you so much. Thank you. Okay. Can I get 99 percentile from YouTube in 1 year? Karthi Smart, you can get 99 percentile from YouTube. You can get 99 percentile from coaching. You can get 99 percentile from self-study. You can get 99 percentile from, somebody coaching you personally. Anywhere you can get it from. It's dependent completely on your hard work, your study, and sometimes whether you are being able to grasp whatever has been told and how much you are able to follow regularly, sincerely. That's all that matters. But I will also tell you, you can also get 1 percentile from YouTube. You can also get 1 percentile from coaching. You can also get 1 percentile from self-study. So both things are possible. It's completely dependent on how you make use of the resources available to you. Okay. Will flux have some nature of charge? No, flux is just a concept. It's a flow of something. That's all. Flux is not a physical thing. It's not like something which you can feel. Flux is just an imaginary thing, just like field. Field is an imaginary thing. You cannot see field. You can experience field. Same way, flux is just an imaginary thing which passes through any surface. So how about this question? Electric charge is uniformly, electric charge is uniformly distributed on this linear charge of wire of radius 1 millimeter. Charge per unit length is given. Another surface is drawn. The question is how much flux will pass through it? Well, it's very obvious now to see that because of these charges, there will be electric field lines coming out of this. And this is a closed surface. The field lines will be parallel to these surfaces. Be careful, the flat bottom and the flat top. So the entire flux through the cylinder is only because of the charge which is there inside by epsilon naught. So the question arises, how much charge is exactly there inside this cylinder? Inside this cylinder. This charge which is there inside will be charge per unit length. Is it given? The charge per unit length is q coulombs into the length of it. So that will be nothing but q coulomb per centimeter into the height of that cylinder. How much is the height of the cylinder? Radius is 50, length is 1 meter. 1 meter is basically 100 centimeters. I hope you see that, 1 meters. This whole thing divided by epsilon naught. So centimeter cancel. So it will be 100 Q by epsilon naught. That is the answer to this question. And is it there? B. Yes, B for Bombay. Very good, Mohan Rao. Very good, Dikshita. Awesomeness, Madala, Tejasvi. No, Kailash, it is not A, it is B. Very good. Very good. Thank you, Venkatapavan. Oh my God, you are from Anantapur, very close to Bangalore. Rayalaseema, I know Rayalaseema. Yes, very good. I hope Venkatapavan. Neevu chala baagundi. Okay. On my EM waves being added to J Advance, will it be medium weightage? I feel, Ramya, they might max ask one question from that. That too, they might even combine it with some other chapter. I really doubt they will give an isolated question. Most likely they will combine it with waves equation or something, or maybe they might just combine it with some energy or intensity related questions, something like that. Okay, let's see how many of you are able to solve this question. There is a long string with a charge lambda passes through an imaginary cube, then maximum flux through the cube will be. Let's start by drawing the cube again. Let's draw this cube. Okay, this is our cube, and yes, I'm not showing the size behind. Now I want to pass maximum flux. If flux has to be maximum, that means that charge inside has to be also maximum. You should somehow see to it that maximum charge passes through it. Who is the charge carrier? The long string with some charge per unit length. How do you place the string so that maximum charge is inside? Remember, it's a long straight string. So how will you place the string so that maximum charge passes inside? Well, if you make the string go like this, oh my God, this is not even seen. If you make the string go like this, I think hardly any charge is there inside. Hardly any charge is there inside. Okay, what if I make the string go like this? It goes like this, okay, like this. Okay, there is a decent amount of charge inside the cube. Okay, now I got some idea. How about making it go? How about making it go like this? I make it go like this. It goes along a face. Oh, now even more charge is there. Even more charge is there inside the cube. But I can make it the highest if I make the string go like this, and it comes out from here, basically something like this. Basically this becomes your diagonal. This becomes your diagonal. And what is the length of the diagonal of any cube? The length of a diagonal of any cube is √3 times basically the side. Why am I referring to that? Because I know I want to find out what is the charge inside, because this is the max charge possible. No matter what you do from one vertex to another vertex, opposite vertices, the diagonal which passes through the center of the cube will have the maximum length. That means maximum charge will be there. So guys, what will this be? It will be the charge per unit length, which is lambda, into the diagonal's length, which is √3 times what is the side? Side is A. So that's about it. So I'm just going to put that value right over here. So this is going to be lambda A √3 by epsilon naught. And is that A or B or D? Well, that is D, guys. Many of you said A, B, D. Yes, it is D. Very good, Sonu, Akash, Kailash. Awesome, awesome, awesome. Such a beautiful question. Such a beautiful question. Okay, so you need to visualize, how can I put the charge inside? All the other cases, the charge is not maximum. think of a room where you are placed and think how can you get maximum length. That will be obviously the diagonal which passes through the center of the cube. That's the answer. Let's move on to the next question coming up on your screen. Beautiful application questions. Kartika Keeta, as a girl, how much marks, etc. I would say leave a comment after the session is over. I'll ping you a link. You yourself will be able to judge which NIT, which branch, etc. Just leave a comment after the video. Okay, so we have a hollow cylinder of charge Q coulombs with it, and phi is the flux in SI units with the curved surface only. How much is the flux through any of the flat surfaces? How much is the flux through any of the flat surface? Okay, options are given, but even without the options, you should be able to do it. There is a hollow cylinder of charge Q coulombs inside it. Okay, there is Q coulomb inside it, so obviously it will be creating flux through everywhere. Where, all right, something like this. Great. Now the total flux through the cylinder, I know, is nothing but the charge inside by epsilon naught. The flux through the cylinder will be flux through the surface A plus the flux through the surface C plus the flux through the surface B. Charge inside is just Q and this is epsilon naught. The flux through the curved surface, it's clearly mentioned, with the curved surface is phi. So the curved surface here is B, so this would be phi. I hope you see that. Now the best part is the left and the right surfaces, the flat surface, whatever flux goes here, the same flux will also go there. So both of them will have equal flux. Here, both of them will have equal flux here as well as here. So both of them are equal. So let's say I just call it 2 times of phi A. Phi A plus phi A will be 2 times of phi A. So naturally 2 times of phi A will be Q by epsilon naught minus phi. So naturally phi A will be half times Q by epsilon naught minus your phi. That is the final answer. It's not C, guys, it's option A. Some of you said D. No, it is not D, it is option A. So that 2 is going to play a big role. Why 2? Because this and this are same. So phi A plus phi A will be 2 phi A. That's the catch. Many students make that mistake, but it's good that you attended this class and you realized what kind of mistakes are probable and you will not repeat these mistakes in the examination. And the question said any circular face. That means either phi A or phi C. Both are same. So that's the answer, which is option A. Now I've kept some homework questions for you. So you just need to solve them. Make sure you put it up in the comment section after the video is over. Solutions in the PDF in our Telegram channel. This is the second question. I'm pretty sure you can solve it. Once you are able to solve these questions, make sure you are solving the assignments, our problem series, our Tattva books, everything. It has level 1, level 2, level 3, level 4 questions, and it has solved examples. Obviously you get assignments, you can get soft copy or hard copy depending which subscription model you are taking. You get in-class quizzes. Make sure you're attending the classes as well regularly and plan a systematic study. Watch my strategy classes, and believe me, if you do all these things, be it JEE, be it NEET, and you prepare yourself with all these questions, nobody can stop you from becoming a ranker. And the best part is all the courses are available for a very cheap rate. So 8,100 rupees, that's our subscription start price, and you get the best offer when you use the coupon code SHHPRO as well. So make sure, no matter which course you are joining, be it English course, be it English, be it JEE, be it NEET, be it 11th, be it 12th, be it dropper, you use the coupon code so that you get the best of the best, highest discounts on any course that you're joining. I'm so happy that you guys enjoyed this class. Leave your comments, smash the like button, it means a lot to me. See you next time. Hasta la vista. This was